My name is Terry Key. I'm a chemist. I'm in fact an inorganic chemist in the School of Chemistry at the University of Leeds. And today I'd like to tell you a little bit about electrochemistry. In the first session today, I'd like to introduce the topic of electrochemistry. What exactly is the subject of electrochemistry? Essentially, it's very simple. We're aware that there are around us a multitude of chemical reactions. Chemical reactions abound. But there are a group of chemical reactions which can be used to generate electricity, and also a group of reactions in which we can use electricity to drive those chemical reactions. Today I'm going to tell you a little bit about electrochemistry, and in particular the way in which chemical reactions can be used to generate electricity. Electrochemical reactions are not the easiest to understand, but they are quite common. They are in fact all around us. So one of the common examples of an electrochemical reaction is corrosion, the rusting of iron. The rusting of iron, essentially what happens when iron rusts is the metal is giving up electrons to oxygen in the air. This is a type of reaction that is very commonly harnessed in electrochemistry to create electricity. The process of rusting is an example of a redox reaction. The word redox is a combination of two different words, reduction and oxidation. Both of those processes involve the change or the exchange of electrons. Reduction is the addition of electrons, and oxidation is the removal of electrons. So when you have a chemical process such as the rusting of iron, the corrosion process of iron, what you have is an electron transfer from iron to oxygen, in this case, from a donor to an acceptor of those electrons. Iron corrosion and iron rusting is something that we're all fairly familiar with. Here, for example, I've got a key, one key of many on my particular key ring. This particular one is quite rusted around the edges. I touch it quite a lot on my fingers. There is moisture, and in that moisture there is salt. And salt is very important within the moisture for accelerating the rate of that corrosion. Hopefully this will last me for a few more years yet, but it's an example of what corrosion can do. Now, I've said a little bit about iron. Iron is one of the common examples of corrosion, but it's possible for many different metals to undergo similar types of corrosion processes, redox processes. These processes can be harnessed to generate electricity. Let me give you a very simple example. Let's consider two metals. On the one hand, we've got magnesium. On the other hand, we've got copper. Two quite different metals with two quite different sets of chemical properties. If we imagined we had magnesium over here, copper over here, each of them was stuck into a small beaker of water. What we would find is that some of the metal atoms from the magnesium and some of the metal atoms for the copper would find their way into the water solution. In other words, they would undergo a process called oxidation. That is the loss of electrons from the free atom to generate a free ion in solution and release electrons. Now, magnesium and copper both have very different tendencies to undergo that oxidation process. So what we have here is magnesium and copper in solution, a buildup of electrons over here on the magnesium compared to the copper. Now, if we connect a wire from the magnesium to the copper, and also connect the two beakers, the solutions within those beakers together via what's called a salt bridge, what we have is the makings of a battery. Electrons are going to flow from the magnesium through to the copper, and we can suck out those electrons and do some useful work with them, like light a bulb. That is the essence of a battery operation. The reason the battery works in this electrochemical manner is because the two metals that we've been talking about, magnesium and copper, they have different potentials, if you like, a different tendency to give up electrons, and indeed a different tendency to accept electrons. What we do in electrochemistry is we give that tendency a number. We call it an electrode potential. In other words, it's a number that we can use to say just how easy it is to take electrons away from something, such as magnesium or copper, or how easy it is to give those electrons back. That number, electrode potential, is a very important number in electrochemistry because it tells us something about the thermodynamics of the chemical processes involved. That means it tells us about which processes prefer to happen and which don't prefer to happen.